Hey guys, so let's talk about how you can create the front part of the DJI drone. This is something someone was curious about in the comments. First, when we look at this thing, we need to recognize just basic shapes usually help go a long way. We only have the front image here, but these are circles for the most part, but you can see if they were forms, they actually go out and dissipate into the back there. Also on the sides here, these are kind of like little trapezoidal shapes or rectangular shapes like so. And so what we need to do is when we're blocking out, we start thinking about how we're going to A, model this in subdivision at some point if we wanted to. But B, we need to think about these primary shapes here, these forms that we're trying to create. So things like this, it's just a cylinder, but it's a little bit rounded at the back perhaps. And we need to do those kinds of things. And that way we can start working them together. There's a lot of little interesting, intricate kind of curves in here as well. And so you're going to have to lay out topology that accommodates that when you're putting this thing together. Now, if you actually take a look at this kind of a shape here in this form, have you done any other kind of modeling out there? If you did something like a hand for a human, this is almost the same idea here, is that you have like your fingers, the cylinders, right? And in between, you might have little areas where you'd have like the webbing of the skin or whatever. And so it's almost the same kind of idea. Now you just have to start modeling out these basic primitives to get started really. And for, the main shape, it's not as hard as you think. It's literally just low poly modeling. If you've ever watched a channel like Infinzia's channel, he does a lot of low poly models. It's the same idea. You're blocking out those basic ideas. And so you can make things happen just by even something as simple as this, like cutting out a triangle. You can even grab that triangle and move it around, symmetrize it if you have mesh machine, or you can use a mirror modifier. You can start making these little tweaks and adjustments like this, just manually modeling it. And it's not really that hard to do. So depending on the shape you're going for, you can do all kinds of fun stuff like this, right? Now I've already done this for this particular piece, and the blockout's really quite simple. It's really working it into a subdivision model where it's going to become harder. Something I want to mention here is when you're working with cylinders, usually you can use a 6-sided or 8-sided cylinder as a base, or you can go up from there. So it could be like 8, 16, 32, 64, 128, or on the 6 side, it'd be 6, 12, 24, etc. And this is kind of important to understand because the 8 base here, you can see we have a vertex in each corner. So at the top, bottom, left, and right. This is so you can do things symmetrically potentially if you need it. But this also works out really well for topology, generally speaking, because now it's going to behave very well. And remember, when you're subdividing, it's going 8, 16, 32. So when you're doing any kind of other mesh, if you were to subdivide it later on, it behaves kind of in the same fashion. You have 4 vertices here, but if you subdivide it, it becomes 8, right? And so keep that in mind. You need to have a similar resolution across your different pieces. And this usually helps out quite a bit. It doesn't always have to be perfect. Sometimes you might have to use odd numbers and weird things like that, but then you'll find yourself trying to end a loop somewhere that if you got odd numbers, you have to end it in a triangle or something like that. So once you've created these kinds of things, and you'll see here we have a 16-sided cylinder. We got this little shape here, which the pill shape, very simple to create these, by the way. It's basically a rectangle like this, and you can hit Control Shift and click on an edge by having edge selection first. Control Shift click, and you bevel these, and you hit C to clamp it so you don't do that, right? So you hit C, clamp it, and you mouse wheel up, and you want to use even amounts here as well. So something like 2, 4, or 8 usually works out well. And this is so you get a center vertex and a vertex on the right and a vertex on the left. This is the same idea as a cylinder that's been split apart. So if I was to take all this here and delete it real quick, let's delete the front side first. And we get rid of the back for just a second. If you take these vertices here, right, this little area, or these faces, should I say, probably better to do it with the faces here. We press Y to rip it. We can hit G and Z, we can move it down. This is virtually the same idea as creating that pill shape there. So you can see later on, you can actually take something like this and attach it back together. That's just another way of creating those for the most part. And you can see another pill-like shape, right? Same idea. So this is where you get this odd number of vertices on this. We end up with 20 because usually you would have these combined together. So it wouldn't be actually 20. It would end up being a 16-sided cylinder And so that's just good to know on that one. And then so once you've created these, you actually Boolean them back together and you start working the topo basically. So things usually start simple. You can see here with the one I've already kind of worked on a little bit. It's not quite perfectly matching, but it's a very simple of an idea is that you're going to start running your topology around in these kinds of manners where it's very predictable, like the middles of the, between the fingers anyways on a character. You can do things like this and you can shift things around and change how it looks and create little different kind of angles and forms and things like that. So if you needed a little section over here, perhaps, yeah, you might have to select a little bit extra on this one, but you might want to try to dip this back in like this a little bit, and that's going to create a curve there. See? So this is what you're trying to do. Easier said than done. It's actually quite challenging, but you're going to ignore doing like the breakup section at first, because there's a couple things to keep in mind. When this thing is actually manufactured, more than likely it's casted in a mold. So it's doing like forcing plastic into a mold, basically like hot plastic, and it cools down and it pops out a little shell, more or less. That's going to be something like a 2-part mold. And this is something, well, happens a lot in manufacturing. That can play a role in how you go about creating things. You can approach creating things in little parts and sections as if it was going through a mold. However, when this thing is actually designed, it's probably done in a CAD software. And this kind of split here is probably done later on. So the big shape overall is designed first, and then they break it into the little parts and pieces and sections perhaps later on. Just make sure they're going to work with 2-part molds and things like that. So 2-part molds can be kind of just one way that manufacturers go about things. There's 3-part molds, there's more parts. And that's something to just keep in mind. Those are usually aluminum blocks that are machined out, and just something that happens there quite a bit. However, there's other types of molds as well. So there's things like sock molds, right? Where it's literally just a solid piece that is, it's able to be slipped through like a rubbery type of mold, basically, like it turned inside out like a sock or whatever, and it can be released that way. But there's also going to be, trying to think of the name here. There's rotocasted as well, where it's like a hollow shell inside or a hollow mold, and they spin it with resin, and then that way it casts onto the walls. So rotocasted is another type of mold to keep in mind. You want to look these things up, but you don't have to master them and fully understand them. But the basic ideas there still can play a role, because things might be CNC machined out. They might be casted in a mold. They might be screwed together later on or welded. So there's different types of joining. There's plastic welding. There's metal welding, obviously. But anyway, so when we have these shapes, we can just grab all these front ones and then shift select the last one. I'm using the Bool Tools add-on that comes with Blender. I'm going to end up doing an auto Boolean union. This is a destructive Boolean. It's not going to create any modifiers. And so usually when you do this, you just want to go back through it and make sure there's no interior faces. Just press A twice, deselect everything, select all by trait, interior faces. And if there's nothing in there, it's nothing in there, that's good. Otherwise, you can try to delete it or go back through and start merging some things. You do want to get rid of excess. Whenever you do a Boolean, you don't always need all this stuff laying out and about. Maybe just get rid of that front one, maybe get rid of the whole thing down the middle, who knows. You just want to get rid of any kind of extras, and sometimes you might want to merge things together, maybe at center points, but usually you want to try to keep everything flat, so you'll try to go to one of the other vertices there and do something like that. So you can see this is a little bit odd looking here. If I was to do this, it starts to make a little bit more sense perhaps. Maybe we don't need that back edge, so you're going to work things up, work them down if you need to. Like you can see, these didn't quite line up here on the surface. We'll have to work those things out later on perhaps. This is where machine tools, having the surface slide feature is quite useful. It's usually on the modes pie and edit mode. So you hit tab and edit mode with the modes pie on. You'll be able to find surface slide there. However, I got to work around the quick favorites. And surface slide will let you move a vertex. You just press G and move it. It's like a temporary shrink wrap to itself. And that's basically what's going on there. It's like face constraint and max. It's really quite good. And you can finish that surface slide, or Maya for that case. But you can actually do that if you need to move things around quite a bit and keep it on the plane. So that's good to know. And yeah, so we can work all this out. I'm just going to merge that at center, merge that over there, or dissolve it. We can merge those at center. A lot of times you'll find it's better to subdivide the edge and maybe push it in there. And if you need to surface slide it, you know, turn it on and then turn it off and balance it out however you see fit. In our case here, I don't know if that back edge benefits us much, so we'll get rid of it. And you can see we kind of got some, it's kind of going together a little bit better now, perhaps. Now, something like this, if you move this edge, you see it moves the whole edge down the side of the cylindrical shape. Not always what you want to do sometimes. So you can kind of leave these alone for a little bit. Maybe just work it out a little bit later on. You could add a loop here at the bottom or something like that, because it's doing something similar on the other side. And so easier said than done, like I was saying, like you're just going to simply make your blocky shapes, and then you're going to work it into a subdivision mesh. You'll find that the cylindrical count is super important. So we have a 16-sided cylinder here because it's larger. We have an 8-sided one over here. Now, if we were to go through this model and start working on it for a bit, we're going to find that it doesn't quite line up maybe the way we want. These really want to run out at these kind of angles here into these areas. And as a result of this, we get these n-gons and this extra edge in the middle. So this actually works out better if we were to have a more segments to the cylinder, even though it seems like we shouldn't. So little things like this are important to keep in mind. Just use a knife tool, start cutting it up, and see what works for you. You can always increase or decrease the segments on a cylinder, believe it or not, but it does require an add-on. It usually helps anyways. The add-on I like to use is set flow, so we can create an edge loop, and we can do something like set flow with that edge, boom, and it's going to do its best to get it right. I don't think it gets it perfect, but it does get it pretty close, and so that's something we can do if we wanted to. On the flip side of this, if we wanted to go a little bit of a different route, we could try doing loop tools and creating a circle right here. This also can work out sometimes. In this case, it doesn't work as well, I think. So that's why I wanted to show you the little set flow method for this particular piece anyways. You can see here, this extra edge down here is actually keeping us from loop cutting. So I'm just doing quick loop cuts into this area. And I'm trying to keep them from running all the way out for the moment. So you work with n-gons, triangles, you work with just basic geometry. You don't have to go crazy here. You can grab all of these at the same time, I think, and use set flow as well, and do them all at the same time. So you just make your selections. But yeah, you just kind of keep working this as something more like a detailed blockout, if you would. You don't have to move straight into subdivision. I think that's where a lot of guys go wrong too, is that they start using that subdivision modifier a little too soon. You're trying to create good quad topology first for the most part. And that's all that really matters. If you're getting, simple triangles, simple n-gons, and using quads works out quite well. So like something like this right here, I really don't want this edge doing this. I kind of want this one to go up over here, but I want this to kind of go along the curvature here. And so eventually I'll have a holding edge like this, you see. So it's a little bit weird to cut some of this stuff up in this manner, but you certainly can do it. You just have to get used to using end poles to do redirects. If you watched my topology fundamentals video, you'll know that end poles are basically something like a quarter of an inset. Super useful and effective. Sometimes you can make little quads like this. You can see we're losing our curvature shape now though. So we might have to figure out something else to do here. It's a little bit not quite what we want possibly. So, trying to merge things at center, yeah, that probably ain't going to work either. So when you run into these topology issues like this, if you can just start to kind of figure out what needs to happen or occur, it could be quite useful to you to just kind of meander through it a little bit and take your time. And don't get too frustrated when you're looking at them. You're going to have to practice solving these issues. It's not just going to magically happen where like you suddenly know exactly what to do like overnight. But you can start to figure out what needs to happen or occur as you do it more and more basically. And it becomes a little bit faster anyways. So we have a quad over here. This is looking okay-ish. On the other side, it's a triangle. If I try to dissolve that, it becomes, a quad, but this one becomes a triangle. So we run into little weird situations. Sometimes we got to kind of think about and see what we can do with them anyways. In this case, I'm not even sure what I would do with that one. It's something like I need to maybe just run this into that maybe. And then maybe send this one over to that side. And then we could probably get rid of that one, maybe? Something like that. I don't know, something like this. Sometimes you got to shift things around. It's a little bit odd dealing with it at first, maybe. You can see it's a little bit better now. Yeah. So those kinds of things will throw you for a loop as a beginner. And just, be prepared for that to happen. It's not going to always go quite the way you think it should or expect it to. So Even something like over here, you can see this little disparity. I think I'm just going to dissolve this edge and just call it a day. I'm not too worried about that, but end up with like a triangular shape here, perhaps. We move this, obviously, we lose the shape of the cylinder, so maybe we'd leave that alone for a second and see what we do with it later on. And we just keep working this, guys. This is all it comes down to, is maybe we just bring that one all the way up like that. You see, it's a little bit extreme, but does it subdivide correctly later on? Probably. If it doesn't, it doesn't. We'll have to do something different. It's easier not to get overwhelmed by this idea that, you know, it's hard to do subdivision. It's the basic rules are not that hard. It's just hard actually executing it, because you have to solve these kinds of problems kind of on the fly, and you have to kind of work it out basically. And it takes some time. It doesn't always happen instantly. And you can see here, like this edge is following from here all the way around. And when I send it all the way to the back of this part of the cylinder, that's probably not correct. We probably want to send it along the front side here. And so we're trying to create these edge loops that might go all the way from one side of this shape all the way over to the other side, right? You can see the n-gons kind of kill our edge flow right now, but we can eventually work these things out. You can see this makes a good logical connection there, right? And so we can start doing this. And you'll see as I do this, we're increasing the resolution, basically. We increase the resolution of the cylinder. So now we're increasing the resolution of the shape overall. You can see if I just push that out, that makes nice quads, right? And this is the goal. And this is the whole idea of that making n-gons video, or turning n-gons into quads video that I did, is now you can start to recognize that a lot of this has to do with just breaking up n-gons, right? Turning them into quads. And it's really not that challenging at the end of the day. It can be overwhelming at first because there's a lot of little weird tricks that you might employ, such as like different kinds of little topology patterns, perhaps. But it's not like it's a little bit more forgiving than you would think. The worst case scenario is you make some cuts and you find that later on you start creating uneven topology, like maybe the surface gets a little bit rocky or something like that, and you have to flatten things out later on, or you have to restart because you accidentally messed it up. But don't be afraid of your mesh. I think that's the biggest problem. A lot of guys get really afraid of like making changes or edits. As long as you're being careful not to, you know, like make non-planar faces too much, like you can get away with a little bit, but if you make non-planar faces, it can make your surfaces look a little bit bad. You can usually correct them a little bit, but it can be a little bit challenging, to say the least. I think I'm going to run that one all the way back, actually. And you see that edge is getting a little bit tight down there now, but I'm trying to preserve that angle. Oh, I kind of messed it up, didn't I? It's this one on top it needs to go to. All right, yeah, so something more like that. All right. See if I can run through a triangle here. Triangles you can use, by the way. It's just that you want to be careful when using them. That's all. Triangles are going to be, when they subdivide, they turn into inpoles. So they are useful. And it's something like doing an inset almost. So it's just something to keep in mind. This one will do this cut first out to where I think it should go. I don't mind shifting the cylindrical shape a little bit on the sides here, but I don't like doing it at the front section, as that needs to stay looking, for the most part, correct. And yeah, so you can see this is starting to work out. This here didn't, it's kind of below the surface here. It's better if you line things up a little bit better. But, you know, if you really mess it up, I mean, you can just kind of roll with it if you need to. Turn it into a holding edge or something. A lot of times you'll find yourself in cramped little corners. Just a little side note, you use Control Number Pad Plus. You can select more or less. When you're in edit mode, you can hit H and you can hide things. Or you can hit Shift H and hide everything else. So if you ever find yourself working in an area, you know, maybe grow it a little bit, just what you need, and then Shift H it, you know. Or you know, use the cursor selector and hit C and left click, or middle click to deselect, and then right click to get out of it and just hit H. So now we won't be as distracted here, perhaps. We can just start hiding some things out. Super useful. So when you don't, that way you're just not getting all messed up in this. You go to object mode, it's all there still. So if you just need to look at it real quick, that's good. Go back and forth between object and edit mode. You can use Control Tab to use the pie menu, or you can set it up in preferences so that it always turns on. It's tab for pie menu. As for the knife tool, some of you guys always ask about this, thinking it's an add-on or something. It's not. It's just you have to customize the knife tool and preferences. Let me actually just show you real quick. I've talked about this in previous videos, but it is going to be under key map. You're going to look for knife, and you can see the K key knife tool under mesh. You can modify these tools here. So you can see that we can change the measurement type to angle. We can do 5-degree increments. We can do things like that, but this isn't just for the knife tool. This is for also bevels and anything else you can get a hold of here. So you can do bevels or maybe even loop cut and slide. You can see here, Control R, right? You can also change things in here, which can be quite useful. So if you ever get tired of, like, say you're doing bevels and usually you have to set outer emitter to arc, you can just automatically set it here. I like to use width personally, and I turn clamp overlap on by default, just in case it's going to have issues. I like to know it's going to have issues with overlap. And if I don't, if it's not too big of an issue, I'll turn it off and I'll still use it without it. And then correct whatever mistake it might have made. But we can certainly go into edit mode and work this now. You can see it just takes a little bit of knowledge on how to control the mesh with the edge flows. And it takes a lot of practice, I think, more than anything else to really get the hang of it. Because you're just making little logical connections, more or less, trying to keep, like this edge going around through here. Maybe it jumps over this shape here, and it comes back over here, and it starts again, right? So maybe we're doing some things like that. You can see this is way back here. If we get rid of that, it'll lose that little edge there. So maybe we just double up the edge here. And you could create spirals by accident. That happens, but maybe we just want to do this anyways and keep all that going straight through there. You'll see this piece is going to become a part of that, basically. So now it'll be something like this, right? So controlling your edge flows, super, super important. A lot of you guys were asking about, like, how do I know when I'm doing like loop cuts, I'm not screwing my model up or something like that. Usually if you're working with n-gons or triangles, a lot of times you can't loop cut through it. So it's one of those things where, actually, I'm going to just merge those to that. I think that'll work out fine, even though it changes the shape slightly maybe, but it's a little simpler, and try to keep things simple if you can, but not always possible, but try to, if you can. Sometimes you got to go up in resolution, so do that. But when you have n-gons and triangles, you do not run loop cuts through n-gons and triangles usually. They'll go through quads, but you can see we got an n-gon in here. These don't have matching resolutions now in this case, so we'll have to figure something else out here to make this work. We'll get back to that whole idea of doing these. You can see that I actually merged down there very well, and these will turn into quads like that as well. Oh, no, they don't turn into quads. Whoops. One is still a going to be a n-gon. So what could we do in here maybe? Trying to run that out to there. Probably not, maybe not going to work out too well. Might have needed that extra edge, actually, now that I think about it. But it's not terrible, but it's not great. Could we add that back? Possibly. I don't know if we will. All right, sometimes you got to use an n-gon. It happens. Sometimes you got to use a triangle. It happens. It's just it's the name of the game here, but for the most part, I try to make these make the most sense as possible. I'm going to try moving them up instead. I don't know how that's going to work out either, but I'm going to try it. Yeah, so we might have to do some kind of reduction here, or go to a triangle or an n-gon or something like that. Or maybe just do another loop cutout or redirect. Something like that. It's just not working in that area very well. So that tends to happen. So you can also try other kind of strange topology that might work out. Who knows? In our case, I don't think it's going to work out, but yeah, we'll come back to that one. A lot of the rest is working out, so that means we're close. It means that one's close too. You see all these want to just run out like so. The top's fine, the bottom's not fine. All right, and so yeah, we keep doing this. Now here's the trick. Real quick, I want to show you guys something. We're going to do these again. I'm going to bring it out here. We're going to shift double click this, Control Shift B into our auto Boolean union. I'm going to run the machine tools cleanup feature, just make sure everything's merged. If we had beveled this, right? We did something like this, all right? Loop slide on off, it doesn't really matter at this point. I just want to show you an example of something. When you bevel something like this, you see how it's adding the, we're doing 2 segments here, profile of, let's do 1. Okay. It's adding holding edges to everything for the most part. Check this out. If we subdivide this, it almost works just as it is. It might be a little bit sharp in some areas you don't want it to be, but this is the idea of holding edges, right? For the most part, that's what your subdivision models need the most. Okay. And so when we're doing things manually like this, and we're working all this stuff in the middle, some guys have different theories on how they like to approach this. I like to work these quads out like this. But other guys just go straight to the edges and they start beveling them as needed. And there's like a certain kind of like bevel order to them, but you can change the shape profile to 1, do a Korean bevel. And you can start to work these things out kind of fast this way. And this is definitely something that's available to you, but it's a little hard to fully understand at first because you have to do things in specific orders. And also, if you're just doing a baking mesh, like you're just going to bake your mesh later on, you can see that one got messed up. Let's go back. This is one of the risks you run with this one. You can see we got something goofy going here. Let's merge these to that. Yeah, so we don't do that next time. All right, so you can start doing this number all day long. But I find that it's, a lot of times it's easier to make kind of a general quad mesh that isn't really ready for subdivision. And I do those bevels last, I think, is probably the easy, in my opinion, the better way of doing it. But, you know, it's up to you really ultimately to decide where you're going to go with these edge flows and all that fun stuff. So yeah, easier said than done, like I said, but it's definitely a thing. You can see every time you hold shift to pan, it kind of turns the snapping back on. I wish it would not do that, but it tends to do it. You got to double tap shift basically. Yeah, so we can get through here. You have 2 options there basically. You can do either or. Some guys like to work with basic primitives and take them up after you subdivide them once. So they'll do like a subdivision, apply 1 subdivision, and then they'll start joining things together with Booleans and whatnot. It makes the Booleans a little bit more challenging to connect back together in some ways, but you get the benefit there is kind of that you don't have to worry about triangles or n-gons as bad because, or like non-planar faces and stuff like that, because usually the shapes are kind of set in stone and you're only working the edges and the Booleans. It's just different workflows, right? You can do any of these whenever you want, really. You can see like we got some doubles going on in here and some weird stuff like that. Sometimes you get a Alt-Z to just merge things. So some stuff like that could happen. You can see that's like it's going to need a cut because it's going to create another vert there on that edge, and then we can merge it back up. And then all of this can go down to that edge, and there we go. And so, you know, if we're trying to do this all the way across down to here and back there, and you can see it gets a little bit squirrely, but is that even going to work out? I don't know yet, but it did create a nice little weird triangle shape. Could we just run it all the way through and do that for now? I guess. I don't know. So doing all these additional edge cuts, you know, this is going to eat up some time, obviously. If you can avoid it, it's probably better to avoid it and just do like the bare essentials. And then you can hopefully do loop cuts in later on. But you can see how these all start to work out. So we're only focusing on this front part right now. But when you're doing a whole object, I want to point this out. You block out this front section as best as you can, right? Try to just standard model it as best as you can. It keeps subdivision in mind, but block out the whole thing because you're proportional modeling a lot of times. And if you're going to do like the motors here or the blades, you know, if those are the wrong size and like this whole arm is the wrong size and the mount needs to be scaled up or something, it might influence how this body piece behaves. And then that might even influence where these line up on that body piece. So block everything out as best as you can before you even approach doing subdivision. Try to get everything just in the right places, at the right sizes. Try to kind of prepare yourself mentally for that, when you start subdividing things, they might lose a little bit of volume perhaps, unless you make it a really dense mesh. So you'll have to kind of exaggerate the sizes of things a little bit. Not too much maybe, but just a little bit. And eventually you're going to start working them out like this. Now this is kind of a slow way of doing it in general. So a lot of guys that are going to go and create models that are just game mesh, right? Or like they're baking mesh. So they can bake something onto a low poly model. You don't do all of this necessarily. You can do kind of little cheater methods where you still use rather bad ingons even. But if you use them on flat surfaces, it doesn't really matter, because if we start subdividing, you can see like this is falling apart here. This is bad shading. You couldn't bake something like that, right? However, if, we took a little bit of time here, we just did some cuts like this. Maybe we put another one up here and another one up here. What if it subdivides now? Okay, not too bad. Could we just do like, let's do an X-ray real quick, top view KCA, cut all the way across. That's going to hold everything in place a little bit more towards the bottom here. You can see like this one here, big ingons, doesn't really matter. It's not really influencing a whole lot there. I was hoping this one would do that too, but it didn't. But if like this was an ingon, it does actually have an issue with that one. Let's not do that. Sometimes you can get away with stuff like that. And so you'll see guys that oftentimes they do just the bare essential for a model. And which one did this come from? The second one. Okay. We'll go back to that same one. They'll do those bare essential kind of edits. And if it works, it works, and they just move on. That's a really quick, easy way of kind of working out topology. You can see we're getting a little bit more involved here. We got some extra edges we might need to cut out apparently. And sometimes guys will just do 3-to-1s or collapse to triangles or whatever they got to do. If it's on a flat surface, it's usually not a big deal. You can see this is all getting a little squirrely in here though. If you ever see a sharp edge like this, sometimes it happens. Here in Blender 3.6 at least, you just right click, shade it smooth again. Subdivide it a little bit more, see what's going on. You can see that little triangle is creating a little pinching kind of area there. Not necessarily the end of the world, but maybe we'd probably be better off if we figured out something a little bit different to do there. We have another triangle over here, so we could actually probably run this out in this manner. Connected triangles. See if that works out for us for just a second. Not doing exactly what I thought it was going to do, but we're going to try that. Yeah, so sometimes there's like weird connections. When you connect to the back of a triangle, it turns it into a quad. And so you can balance that out and wrap it up and make sure you just keep that cylindrical shape perhaps, and boom. It should look a little bit better, but we created the pole manually that it had. So we can just balance it if needed. Not a big deal. Yeah, so there you go. If you need this to stretch out more, this is where the surface slide really comes in handy. You can turn surface slide on. You can grab like a whole patch, something like this perhaps. You can just move it out, scale it, right? Take that whole edge, bring it out. Take that edge, bring it out. You can even rotate them a little bit if you want to correct the setup there. So this model, or this drone anyways, the real one, these are pretty soft actually here in the back. And so when you start doing stuff like that, it's not really a big deal. You can just surface slide things around a little bit and start to work out that curvature a little bit. It might get a little bit snappy, like it doesn't move quite the way you want it to, but you just take your time with it and see what you can do or what you can achieve. Probably, save this before you start doing something like that. So that way, if you mess up and you get past all the undo limits, you can just reload the file, or you can just duplicate it out to the side real quick and play around with it and see if it works over there. Sometimes, doing edits like that might not work out so well. You can see it didn't do too bad, but definitely probably could have been better. This one, I think I'm going to just cut to there so we can get rid of that one. Shift that midway. These two could probably merge. yeah, so you just got to kind of play around with these for a little bit and see what you can get going. You want to space these out using spacing with loop tools. You just grab a string of verts like this, loop tools, space it, and it'll go across the middle there like that. Super effective way of getting things going quickly. So you can do that up here as well. Not a big deal. Eventually those will go to the back, right? So another kind of thing about those loop cuts, right? Like if I loop cut here, you can see we're loop cutting all the way across this shape, and it dies here in the back because we have big end guns. That's just one way you can approach that. You could delete these, and you can also have it so that none of your loop cuts will run through the model. On top of that, you'll notice that these front cylinders, a lot of times guys are like, you got to grid fill these things and all that to make them good topology. And that's true, but here's the problem with that. If you do it right off the bat, you loop cut, it's going to send your loop all the way through it and around the model. I don't prefer that behavior. I'd rather leave an end for a bit, and then that way I can work up to it. And then I could say, like, I don't need this extra edge here because that's going to cause it to flatten out in that area. So I would probably try to figure out, do I need to do some kind of like redirect in here before I get to that point or something? Is that a possibility? And of course, we're creating a pole, so it's also going to create like a little weird topology patch here. Cylinders are very picky. Curvy shapes are very picky. They like the quads. They don't like the additional edges going through them. So if you ever had to do like a detail over here, you're just cutting something in, and you had, for whatever reason, an edge going down in that direction, you redirect it maybe back here on the flat face, not over there. And that might give you a better result. So you can see, you can do things like that. Just create that little end pole basically, and we'll get rid of all that. We don't need it. All right. And at some point later on, that's when you start doing like your insets on these things if needed. You can push them in. So let me turn that surface slide off. So you can inset hitting I, and you can hit I and then hold control and then an I. If you want to even do these in like a batch like that, I guess you could. It's better to match your reference, of course, but you could do things like this. And on top of this as well, something I do want to mention is like you can use individual origins. You can press E and S. You can scale each one of these up if needed, or let's delete them maybe. We can select these areas. We can press E and S. We can manually solidify things. This is not a problem. So if you want to create this in kind of like parts and pieces, you should. High polys are usually made in somewhat of a realistic fashion where you have the same kind of parts and pieces as the real thing. So later on, you can grab this loop and press F, Alt-N, flip it. If it's backwards, P, separate selection. And so now you have another piece in here like so. You can see with the volume loss does cause a little bit of a problem in this case. Put the origin point to the center. You might be able to just scale it out a little bit. But this is a good practice sometimes to do things like this, because you might be trying to create like lenses that have some weird insets and stuff like that. So, and eventually, you could try doing a grid fill here. The grid fill may not give you the exact topology you want at this point, even if you're trying to do things like proportional editing and all that. And so this is a great time to understand how to create cones or use quad spheres, and also more simplified geometry to create curvy shapes like this, perhaps. So, but yeah, you can do this just like this, guys. And this is like, it's not too challenging. Like I said, it's just it's kind of challenging when you're a beginner. But look, we got like big n-gons over here that seem to still be working for some reason. That's weird. I didn't expect that, but we're gonna have to more than likely run this one all the way around. I have a feeling it's gonna go somewhere through like this, maybe. Right, and it'll come back through the top perhaps, and there's a good odd chance it's going to run into an area like out here. You can see if we had done all that on the inside already, we're going to be spending some time here trying to work all this in this area, going all the way across all these shapes perhaps, or whatever ends up happening. But it's a possibility that happens, so it's something you do want to avoid potentially, because we'll see that. Well, first we have this guy needs to run over. This one still needs to run over. Apparently, I didn't expect that to happen. So this one we might have to redirect it actually, and we might just send it to a corner like that, and then start sending it down. You see what I'm saying? So there's little things like that that can also occur sometimes. You don't always get perfect topology sometimes. It's not that you don't want to create perfect topology. It's just that you just simply can't. Subdivision, there's certain things that will not work with subdivision. There's certain types of shapes you just simply cannot create. And if you try, it will not ever happen, because it'll require you to create a spiral, and then you would end up having to spiral it infinitely, and then that's not what you want, right? So you'll have to run it into a triangle more than likely. But you can see here, that starts to work out like that. It might not deform in that corner just the way we want. So there would be other options available, perhaps. Maybe we can do things different in here. Usually, if you have a higher segment count on a cylindrical piece, you can work the corners a lot easier, right? But if you're trying to keep things as simple as possible, you know, getting it well enough, I think, is probably the best you can do. So you can see over here, like, we need to maybe push these into there. I don't want to move this whole edge. If I move this or merge it down, you see it moves the whole edge. So I would probably do another cut here. So I'm only moving it at the very end there. Slight distortion, sure, but it's going to work out better, I think. Just like we were doing earlier. And around and around and around we go. So you do a lot of this stuff first before you even focus on doing panel lines, but you need to be thinking about those panel line cuts and other additional details perhaps as well that you might be placing in other areas. So if you had to have like a cylinder here at some point, if we look at what it's doing when it subdivides, this might be pretty hard to add a cylinder into this place because of that pole. So, you know, you do need to think about turning optimal display off and what you're actually generating here. Because what we're working on is actually just the cage mesh. It's like the control mesh. This isn't our model. This isn't the end result model. We really need to focus on what this thing does when it subdivides. Because if we need to take it up a subdivision level, we're going to need to take it up a subdivision level. And in that case, if it's not doing right at that point, it's going to make it harder to work with this thing, basically. All right. And so we can run these ones out, perhaps. Run that one to there for simplicity reasons. This one needs to be reduced, I think, right here. I'm just going to do it kind of dirty real quick, but yeah, I don't want to get too involved with all that. Maybe I can reduce this whole area like that just for a moment. Those are quads, technically. It's probably not going to look good when it subdivides, but yeah, it definitely does not look good. I just want to get it going. These might be better. Turn proportional edit off, spacing them out a little bit more probably would look a little bit better. And of course we would need to add some holding edges there at the base of it. Missed that one. Let's go. Okay. So you can see, like, still it's not looking too bad, but it's not maybe as good as we want it. This whole area here, I'm going to control click around. I just want to show you this. You can do this one if you needed to. You see we softened it all back here already. We got an N-gon right there, apparently, that I did not deal with. I'm going to run it into a triangle just for the time being. But if we control click around here, we got everything working at least. These kinds of edges like this is why you don't have to always add holding edges right away, because you can, a lot of times you can bevel these. I had to turn clamp overlap off on this, so something's wrong somewhere. But sometimes it's not too bad with clamp overlap off. However, you can see, you can bevel these later on if you want that to be a little bit sharper, perhaps, right? Like, that's a possibility. You can do that with a lot of edges. You can see the way we had worked this, of course, it didn't. It's all like flat through here where it's been beveled. It's not really quite what we want, maybe, but it's still the idea that counts. And yeah, so if you ever have to do that, you have to do that. All right, you see how they're all collapsing back here? It's creating some really bad geometry or whatever. Just delete that for a second. We'll worry about that here in a moment. We still have a lot more to do. It takes time if you're just going to cut it all up like this. But it's not too bad. You can select a series and hit J. That's something you can do, is to join those. J to join through. This one looks like it's going to go to there. So this will eventually go to a loop cut up here. So we can select the series J and then loop cut. And because we don't have a back face, I know I'm not messing anything up back there. See what I'm saying? We're not cutting through the whole model. We're just cutting to that back empty section. We might get away with that if later on we do something a little bit different over here. Or maybe not. Maybe we just run it to a new edge through here. Like that. That'll do something like that, maybe. Might get away with that one. Who knows? Yeah, a lot of little cutting taking effect here, but this is an ideal situation where you create perfect little squares. And that, trust me, it doesn't happen that way. Hard surface, a lot of times you'll find that you need more density on the edges anyways. And it's not so much about deforming it a lot of times. Whereas like perfect squares usually deform really well. This one, maybe not. We can go to there or we can go to there. If we go to there, I'm dissolving that one through. Right. Now I give us a quad like that. So that makes a little bit more sense. Now we can loop cut here, join there. These can all be joined together. And we're creating a nice little patch like this, which is great. And you would think that we go through this whole bit of trouble here. Loop cut to that middle. See, we're going to do that back here as well. Add a loop cut as needed. We can just join these now. Okay. You think we go through all this trouble and we'd have like the perfect mesh and we're done? No, not really. What's going to happen is we still have a lot of little minor details to do that we did not hit in that blockout. And you can do these on a higher resolution mesh, but you can't do them on this low resolution mesh. So sometimes you're going to apply a subdivision and keep working this basically. That's a possibility. And if your quads are just not working out for you, they're not working out for you. So we can pull that one up there, maybe dissolve that to there. That can all go away then. You see how that works out? A lot of little things we can optimize still and tweak perhaps. See, that's probably where that clamp overlap failed. It didn't quite work out. And this really wants to go all the way like down there. That's nonsense. We could probably get rid of that one at some point. We can bend it right there. Yeah. Okay, that worked out better actually. So, yep, there we go. And see, it's almost done down here now. I'm going to run these out real quick. I'm going to show you how you do the fill at the back. So there's a little trick. When you're doing asymmetrical objects, they're a lot harder. When you're doing symmetrical objects, it's quite simple. However, if you leave a little section kind of open somewhere where all your geometry kind of runs to, all your edge loops and all that fun stuff, a lot of times you can select this as just a big open face. You can see we have 37 vertices right here. And so we need an even number. And that would actually allow us to close it up, basically. So you see here, you either miss something, you just got to find a way to create an extra vertex, basically. In our case, so we get 38. Now, a lot of times, these big flat sections like this, especially, you can grid fill these and work them out as needed. If you want to do it manually, you can just press F and go through and start, making logical connections here. But a lot of times, that grid fill will tell you kind of what's going on here. You can increase the counts perhaps to like 4, and you can change the offsets and play around with how it's going to fill a little bit and see what kind of results you can get out of it. Maybe keep it simpler. Doesn't always work out, but a lot of times it does. You can also try simple blending and see if that helps it as well. Yeah, so you can get quite a few different results out of that. I don't care much for that one. It's interesting, but it's not. It's an odd number. Maybe that's part of the problem. It's pretty close. It's not too bad. Okay, let's try and run with that. Sometimes you got to, you get it close enough and you might be able to fix it up. All of this stuff here is just nonsense. I don't know why that whole section looks so bad. You can select all the faces and control exit. Yeah, so we would need to balance this definitely. Working these edges either up or down, like you can collapse some of these, do 3-to-1s. There's just different things you can do. You can make this look a lot neater back here if you wanted to. I think for this video, at least, we're not going to go through the trouble of doing that. A lot of times, I'll find myself just doing a straight fill, and then I'm just going to start making connections where I want them and where they make the most sense, you know? So like these two here maybe make a lot of sense. And then I'll start working this whole model backwards, basically. Like I need an edge down here to hold all that a little bit tighter. I might push that out. Who knows? Things like that, right? Try to even it all up. So it's a little bit of homework, you know, like it's left over from the model that you got to just eventually deal with. But it's not that bad, usually. Especially if you think about this as you're working on it, which I wasn't, but you'll be able to space it all more appropriately and run the edge loops all the way around the way you think they should be and whatnot. And so you can see we got a little bit of an issue here with that one. Maybe we just pull that down to there. You just do joins as well. So you can see like maybe we just need to do some additional cuts. So we didn't even finish the bottom side here. So that might be part of the problem, but all right. You can see all that working out there. Okay. Like some of these are a little extreme, honestly. You could probably reduce some of these in here. Sometimes you can even reduce it all the way through the shape like that. Not always can you get away with that, but this is where those bevels come into play because you really want to have that corner piece so you can reduce every other. But you'll see ours are actually needed for this piece here, so we can't actually get rid of that. Not like that anyways. But we can try doing some 3-to-1s maybe. If it's a flat surface, you know, it's not a big deal. Creates a quad, not a triangle. It's just going to have a pole in it though. So you can see like that whole section there is starting to work out basically, right? Start doing things like that if needed. Also, this will influence your unwraps. So if you're going to UV unwrap, you know, some things like that can come into play. You can see like that whole section there, you can maybe just reduce it, use the triangles. Yeah. Rather cool stuff you can do with these models. Right, yeah, so basically that's going to be like step one. Create a nice clean mesh this way. Start working it as best as you can. And then what you want to do at some point, more than likely, is a lot of times I'll take these up a level of subdivision. You can also use creases, guys. Like you don't have to always add additional edges everywhere. You can use creases at this point. I'm going to show you how this works out with this real quick. Like, so you do something like this, and then maybe over here we want to apply a crease as well. We'll see if those creases work out on these. I'm just going to set them to a 1 real quick. Level 1, subdivide this. Okay. Okay, so it's going to hold it a little bit sharper in this area. So you'll see here that this is what it's doing without creases, with creases, right? So if you were to take it up a level 2, you get this result. This isn't really good flow here on this edge, but for the level 1, I think will be okay-ish. And we can apply this now, right? So this is where you'd want to duplicate it out possibly, because this is, you don't want to mess with that one maybe. So if you mess up here, you got something to fall back to. Anyways, we now have those creases. Let's get rid of them. We subdivide it, applied it, get rid of the creases. We can rebalance these if needed. We can just GG twice a little bit, make it look a little bit more appropriate. So next time we add a subdivision, that'll hold just a little bit tighter in that area. You can see every time you subdivide up more, it gets a little bit sharper perhaps. That is one of the downsides of using creases to start that kind of a topology, but it does happen. So we're at a much higher resolution now. This is where you can start really thinking about, you know, what little details you might need. You might do loop tools and do like circle, turn off flatten perhaps. If you don't need it, maybe use radius. You can start making little tweaks and adjustments like this. This is another time that using surface slide is really good. So you could do like loop tools, circle. You can even use flatten or regular or whatever. You can actually scale these, move them, rotate them. Just keep it kind of in line with itself. And so surface slide is super useful for that because you'll get a slight distortion out of it. but it's not really too bad. Especially like when you scale it up a little, you can smooth it a little bit maybe, and then loop tool circle it again. All right, maybe do a little inset and then finish it, and then press E and extrude it down. All right, so now you're doing this kind of number here. If you have the topology here to hold these details, you can do this. Otherwise, you can't. On the flip side of this, some of this stuff we could have adjusted earlier, which I didn't actually do. Some of these things, like in this area, for example, would have been running out to like the very tip here, perhaps. It would have been all smooth. And it's kind of hard to do that at this point to some degree, but you have options always. You could try smoothing vertices and hitting Shift R, or excuse me, that's a bad habit that I do. You can just Control V, smooth vertices, and you can try bumping up the repeat amount here and see what kind of behavior you're getting out of that. You might be able to smooth some things together, perhaps a little bit. That's not exactly probably what we would want there. So doing additional edits, even on this one, would have probably been a good idea to do a few of those. So like this, for example, here, we look at the reference images, you can't really see it here, but it's like some really intricate little type of curves occurring and whatnot. A lot of these edges here are actually going out something like this, almost all the way to the end of this thing. And it's not held sharp here at all. Like it's not a sharp piece. This is where you start finding that you can balance things and you can start doing numbers like that, right? So you can start deforming this mesh basically. And that's the idea of using quads in general. You can see since we filled that back section, we now created a spiral by accident, right? So we would want to go through and make sure we maybe keep that spiral from occurring. But I do want to cut through here so I can control the curvature, kind of like what I was talking about earlier. And, you know, it's subdivision mesh. So if it becomes non-planar a little bit, it might be okay. Sometimes it's not, but you can see that works out pretty well, except for we need to take that edge a little bit further through. And look, we can, in fact, use n-gons, guys. It's not really a big deal necessarily. If you're planning on sculpting on this later on, though, it is a big deal because you can see we're going to get an E-pole, an N-pole. Those poles create really bad sculpting results, basically, if you're going to do that or go through that numbers. So you can see I didn't finish this model entirely anyways, so it does take some time to get it just right, just perfect. However, that's the process, right? So even when you're doing the edges later on, like you know, you're trying to create those edges through here, it wouldn't be bad to maybe create an extra edge in here exactly where it needs to go, right? If you're going to do some kind of slice or a cut, because these ones were sliced at the front or whatever. And you can see on my original model here, I did in fact go through that process. So we're looking at, you know, I split it up later on, but that's when that happened basically on this one. You know, we're looking for these kinds of edges here that we could potentially utilize to create a split basically. So if you create a loop all the way around that area, you can do select loops, select inner loop regions, and you can see you can select both sides of this mesh. All right, now you don't have to separate it here. You could separate it later on down the road, but eventually you separate them. That's the main thing. And so this is where a lot of times you're going to end up doing things like solidifies. You would maybe do that after the original subdivision, and you can actually add another subdivision after the fact usually. So sometimes that works out really well. Find the right thing there. Okay, so yeah, you can see a lot of times that'll work out really well because if you do the solidify after, well, if you do it before the subdivision, it loses a lot, right? If you do it after, it loses less, but it's always not perfect. So it's a little bit tricky sometimes to get that to work and behave the way you expect it to. And this is a lot of times the reason why I don't even bother with the solidify after a little bit. Solidify, you can also crease on the inner or the outer side, but a lot of times I just like to take these pieces here and I'll start working these manually. That's just how I personally like to do things. Even if Solidify does something different or similar, I just find it easier to do it a little bit manually, you know, maybe do certain edges, not all of them. And then I can go back and fill these areas, right? Cool. Use the F2 add-on if you have it. F2 add-on is pretty useful. But yeah, we can start doing that number all day long. And you can make these actually meet up with each other in kind of interesting, intricate ways. It's a possibility that you have like one that kind of overlaps the other and one sits underneath the other. So we're talking about doing things like that. I usually it's better to do one side and try to reverse the faces, like duplicate them and reverse them. But it's not impossible to do. Let's see if I can get that going out in the right direction there. So you can make some kind of interesting little shapes like that, right? And as a result, when we do this side, we could do literally the same thing. You can also vertex snap these, and you could just try to get them going here with the vertex snap. You can see it wants to go to the center. So this is one where you're going to want to use the active element. Oops, sorry, that's not the one. Under vertex snap, you can use active, shift double click that edge, and you can snap it, extrude it, snap it, extrude it, snap it. You see, we can actually make these things match up, even if we do them manually. Not really a big deal. So this is going to work out usually a little bit better, especially if you add your holding edges to it. But even right now, it probably wouldn't be too bad if I had, went through and did a little bit more, perhaps. But you can see it's starting to work out, and that's going to keep you from accidentally creating just nonsense usually in these areas. Eventually, you'll have to have like additional loops on the edges of these, right? And so you can see. Let me turn that subdivision off in edit mode. We can grab this whole section here, grab that vertex, and then just snap that vertex all the way through. And do something like that, merge it so we have a little bit more to look at here. Yeah, you see it's starting to work out there with that holding edge. With this interior section here, turn subdivision off on edit mode. Probably get away with selecting something like this as well. If you had it selected all the way through, you could probably bevel it, right? So there's always a possibility of doing that as well. And then that's going to give you a really clean beat up here, basically, that you just simply won't get from that solidify modifier. And it looks cool if you're doing like breakdowns as well. So if you needed an object to fall apart or something like that, you definitely want to think about doing this kind of stuff. I think it's a nice touch anyways. And it's not too hard to do. It's rather simple, right? The active element snapping goes a long way. Just clean things up with machine tools. There you go. You might have to rotate those a little bit or just tweak them slightly. There's snapping alone is not going to get you the result you want. But for now, I think you're getting the idea here of what's occurring. All right, now, big thing. Let's see. Since these would probably be two different pieces the way we're doing it, the bevel there would not maybe be as useful. Well, it wouldn't necessarily be it wouldn't be like we're doing a low poly, like or we're baking a high poly to a low poly, because we'd be baking two different pieces. I mean, we're still going to bake high to low, but it's not going to be a normal, basically, is what I'm getting at. Not a normal like you would on, like if this was all a big low poly piece, right? It's going to be two different pieces. So this could work out a little bit different with the normal maps because we're really just doing one piece at a time. This would get the normal bake on it, perhaps. And so this won't necessarily reflect what it should. But I want to point something out here. When you're creating normal maps, you'd use a normal map mat cap like that going up there at the top. When you're doing these edges, you don't want them to be like super thin a lot of times, because if you're looking at this object from way back here, you can't see nothing happening here. So it depends on the size of your object, whether it's a simple prop in a scene or if it's some kind of hero prop. How tight you're going to make these bevels is extremely important. Also, depending on like what type of materials they are, and et cetera, et cetera. So you can see here, I think I did it on this one. No, I didn't. A lot of times you got to like scoot things around and maybe even create like little sections that kind of open up a little bit like that, and do these little chamfers or tapers to things just to give them more normal map information, because you see that's going to be a little bit more than this one down here. And so subsequently they have a nice little gap in there, but let's just bring that edge down just for a moment. If you do that a little bit on both sides, It'll give you something a little bit more obvious, right? So, match these things up so there's no gaps. But if you make your normals a little bit more pronounced like this, it's going to look much better in a video game than it would with something like this. And so, even just creating more rounded bevels even could potentially help out here on something like this. Even if you got to like dissolve an edge and do something like that. I mean, maybe that's a possibility, do that. But in our case here, I feel like just backing these up would probably be our better bet. So it's just a much bigger bevel. And that's what's cool about subdivision is you can make variable size bevels rather easily. So you can round that out quite heavily. And so now that's going to be much more readable when it's only a couple pixels big. And I think you get the idea there. Like we can actually make that kind of stuff happen and occur. Yeah, it might be exaggerated, but that's the way most stuff is in game engine anyways. It's exaggerated to some degree. And you probably want to do that anyways. But you're going to have to find a balance for it. You're going to have to find what works and what does not work for your, maybe your art style or just for your project in general, for your, how big these things are, where they're placed and all that other fun stuff. So yeah, just go through that process a little bit. And if you are doing just a quick bake mesh as well, just a side note here, I'm going to try doing it on this one maybe. I wanted to do it on this one. I don't know if that goes all the way around. Oh yeah, it does. Okay. If you're just doing a bake mesh and you're not going to split these apart into two separate pieces later, you could just do like a loop cut and Alt-S that in quite a bit. And when it subdivides, you get that nice heavy bevel like that. Something you possibly could, like a little crease or whatever the case there. Maybe push it in a little bit less. And you can see. Very dramatic. Also, turn cavity off when you're doing this. Turn outline off or any of that stuff. And just look at this like straight on with just the normal. You might even take the matte cap and just turn it to like a really bright one. Oops, sorry. No, turn it to the normal one. I'm thinking of something else anyways. But yeah, you could do this. So you're not distracted and you're getting more basically the normal information than like additional shading and whatnot. And so yeah, that's the process, guys. You can do this. It takes a little bit of time. It's a little, and especially if when you're doing the whole thing, it takes some time, right? But that blockouts, that's the starting point. Like that's how you run through these models like this, and eventually start to get them to like some kind of insane level that you want them to be. It takes time with the subdivision to do this. Now, is this always the best way of working? I'm not going to say it is. Certain things like this, you can use Boolean Ngon workflow. You can use the remesher here in Blender. You can take these things over to ZBrush. You can do Z remesher. You can do all kinds of work over there as well. Even from something like this, you maybe make it a little bit more rounded and beveled and whatnot. But you can always take it over to ZBrush if you needed to, right? And just keep working it. Basically, have fun with it. The tool you use is not as important as how well you make it, right? Like if you're going to use ZBrush or Blender, it doesn't matter. Make it look the part that it needs to look when it's inside of a game engine. That's all you got to do, right? That's always the goal. It doesn't matter. Workflows change depending on like studios, whatever studio you end up at. But it varies artist to artist as well to some degree. So, just have fun with it. Become, do what you can do the best that you can do with the tools that you have. That's all you got to do. Don't feel overwhelmed by any of this stuff. It's all 3D modeling at the end of the day. If you can master doing subdivision modeling, I'm pretty sure you'll understand Boolean Ngon a lot better by the end of it, because you're working with a very strict set of rules here when using quads, Ngons, triangles, and pulls, equals, all that fun stuff, right? And so being able to do those loop selections like that, there is not a shape you can't make in subdivision or using standard modeling. But when you're using Boolean tools, it's a lot harder to understand how to approach topology issues that you might be having with that, and when you should be doing cuts in order of things and stuff like that. So they're definitely two that you need to learn how to do, and they both complement each other at the end of the day. That's what I'm getting at. Because you can see here, you can still do Booleans heavily to create these basic shapes here, right? But you're going to subdivision, you keep them basic. You don't make them all beveled and nice looking. However, if you're going to use like a remesh workflow, you might just do bevels all over the place and high cylinder counts and all kinds of other fun stuff. That's a possibility, right? So you know, the choice is yours on what you ultimately want to do with these types of situations. But hey, just I'm going to end this video here and just say it again. Okay, block the whole thing out. Block it all out. Get it looking mostly correct before you move on to this step. And don't do every one of these engines, perhaps, right? Like if you can get away with repeating elements, then use repeating elements. But use instances or whatever you got to do. Just work, you know, like the smallest amount of stuff you have to work, and then just make sure it's the right sizes and proportions first. I can't stress that enough, because if you find out like this is the wrong proportions later on and you have to change this somehow, you can't. You're going to have a really hard time trying to do it. Sometimes you can't. There's little tricks sometimes that go a long way. Like maybe you took all this and you joined it back together. You might get away with doing something like a lattice modifier. Okay, and you find the lattice modifier. I'm gonna use the modifier list add-on here. Lattice modifier is really great. You hit the little icon there to create the gizmo. You can now take this. You can bump up the segment counts if needed. Right, really great little tool. But when these are split apart and they're not merged, here's where you run into a little bit of an issue. You can select those points there. You can start deforming it. You can see I didn't merge the lenses. That's already problem number one. But if these vertices don't line up with each other perfectly, you're going to end up deforming this mesh in a way that it starts creating problems, basically. But you can see how cool this can be as well, because you can do stuff like this. So you can make big proportional changes still, but you might lose like your bevels a little bit, your edges, your cylinder shapes. Little things like that start to happen. So it's really hard to change this kind of stuff to some degree later on after the fact. But there's also a chance that you could change it as well. So it's really quite an interesting thing you can do here. I just wanted to mention. So absolutely do your blockouts as best as you can, so you don't have to do this stuff later on. But it's there, it's available if you need it. All right. It might be a possibility for you. Some guys use this. One of the guys that watches this channel, he uses this a lot for vehicles, trying to get the dimensions kind of right later on. So it's there, right? That's all I wanted to point out. I personally I try not to use it unless I have to. It's a really cool tool. It's something I used to use a lot more, but it's not. I'd much rather get the blockout right from the start in these days, instead of trying to artistically explore the forms after I've done a bunch of work on it. You know what I'm saying? So anyways, that's I'm going to end the video here. I think you guys get the idea on how you can kind of approach this stuff now. It's rather interesting to be able to get to this level of subdivision modeling where you don't feel troubled by anything necessarily. Like you understand what it can and can't do, and you start to really understand how to run edges and loops. And you'll, once you get to that point, you're not going to ever question whether you can model something, right? Everything I showed you in this video is like what you're going to use like 90% of the time. There's a good odd chance you're going to be doing just pushing and pulling polygons with SubD. That's it. Basic Booleans, basic shapes, and working it out. Topology solves, right? So anyways, that's it for this video. I hope you enjoyed, and I will check you out in the next one. Take care.